Okay, logic structures. First of all, let me ask you a question. What would a program be where you can't choose to do different things? What would a game be if you could only do one thing? It would be like a book. You couldn't choose to go that way, go the left way, go the right way, kill the left monster, kill the right monster. In Microsoft Word, if you only had one text choice, if you could only make one type of document. In Photoshop, if you only had one brush, one button. In order for a program to be a real program, a program with which we can interact and tell it to do different things, the program must be able to receive input, which we have seen previously with the input function, but must be able to check certain conditions to do different things. Let me show this and explain this in a bit more detail with this example, little drawing diagram thing right here. Let's say we have a program that checks for a username and a password. This is our program. Now, depending on what we write in as a password and username, the program will do two different things: log you in or not log you in. Now, there's three different things that we can do. We can type in the correct password and the correct username, shown by this circle, the wrong password, and the wrong username. Or we could actually have the wrong password and the wrong username. But let's stick with this for now. Python gets input through the input function, and then it must check the input to see if it is the correct password and the correct username. If it is, it will log you in. Logging in represented by the red circle. If it's the wrong password or the wrong username, it will not log you in, and this will happen. So depending on what we give Python as information, Python will look at it and do two different things depending on what we give it. If we give the right password and username, Python will execute a different part of code which logs us in. If we give it the wrong username and password, Python will execute code which tells it it's the wrong username and password. Now notice that if we have the wrong password or the wrong username, Python can, for both these things, execute the same code, do the same thing. Now, maybe this is still a bit vague. Let us just create this program, of which we have the plan here on the left side. We want to check for, let us begin by checking for password only. So we create a variable that is called password, and we make it equal to, well, we begin by making it equal to nothing, just to create the variable. Now we want the user to enter his password. So what we do, we get the user's input. We've done this before. Input, open brackets, quotation marks, and a sentence to tell them what we want. Please enter your password. So, this line of code will ask the user to enter his password. Once the user has entered his password and pressed enter, we want Python to check whether the password is correct. First thing, we need to tell Python the correct password. So we create another variable that holds the correct password. We call it password correct. Notice I use the underscore here to connect two words in a variable name because you can't have blank spaces in a variable name. So password correct. Let us say, what password will we create? We want to create a string variable, of course, because it's a word, an array of letters. What type of password would we like? Let us call our password Newton, like every science teacher in the world. Newton. Okay. Now we want Python to check whether whatever the user inputted, so what is now the variable password, whether that is the same as the actual password, which is Newton. To do this, we use logic structures. The basic logic structure is if something happens, if something is true, if something is the way it is, then something else. We use this in everyday life reasoning, and it's a fundamental part of our thinking. It's the cause and reaction. If something happens, then that. If I study hard, then I will get good grades. If they shoot a goal, then they will win. The same with Python. If password, the one inputted, is the same as the correct password, then we will be logged in. In Python, this form of logic is written down very simply and almost like in the English language. If, notice that it is highlighted, showing that it is an operator, meaning it'll do something. If password, if this password that the user has entered is equal to password correct, then print you have been logged in. Okay, let's go through this step by step. First, we begin by telling Python that it'll only execute this line of code if this condition is true. So, if password, the variable or the password that the user entered, is equal to password correct, the correct password, then Python will execute this line of code. If the password that the user entered is not equal, then Python will skip this line of code, ignore it, because this condition here is not true. Now, notice that I used a double equal sign. In Python, a double equal sign, one after the other, is used to evaluate if something is true, or if something is a certain way. Here, I use one equal sign, because I want the variable to be set equal to this. This line of code makes this variable equal to that. Here, we do not want to set the password equal to this password, the correct one. We want to check if the password is equivalent, if it's the same thing, which is written by double equal sign, as the correct password. You're probably going to forget to put these two equal signs in there a lot, and it's going to cause you a lot of pain, so just remember it now. Double equal sign is used to evaluate if something is the same. So what we have here, our program that asks for the password, okay, only the password. Now we put the correct password, then this line of code will execute. The print. If we put in the wrong password, then another line of code will execute, which we haven't written yet. But this will not happen, because this condition is not true. Now we want something that will happen only if the password is incorrect. So, if password, I just noticed that I misspelled password up here. If password is not equal to password correct, then print you have not been logged in. Now, this little bunch of code is exactly the same thing as above. Just it only executes if the password is not equal to the correct password. Not equal or not the same, not equivalent, in Python is written as exclamation mark and an equal sign. This means not equal. This is a form of notation specific to Python and some other programming languages, but it's pretty easy to remember. So if we write in a password, which is the wrong password here, then it will move and execute this line of code, which prints you have not been logged in, but not print this line of code. Doing this as using if-then statements, we can check for the input of the user, and depending on what the user does, depending on what happens in the program, make the program react and do different things. This is the case in every single program you use, because if I click File, then somewhere in the code that made this program here, or let's do it in Paint, if I click this button, the tab up here changes. So in this code of Paint, there's a thing saying, if this is pressed, then this is shown. If the password is correct, then this is done. Now, both these things evaluate the same thing. They check for the password. Now, there's a faster way in which we can do this. We can put both of these and combine them into one if statement. So if the password is correct, then you're logged in. Let's just delete this. But else print you are not logged in. What this does, it checks if the password is correct, and if it is not, if it is anything else, whatever it may be, then it does this line. So if it's anything else and not this, then this will happen. Now there's another thing you can do, and that is called else if, elif to be exact. What this does is, I'll just write out a line, elif password is equal to hello, then print. This is the else if part of the code. Now, what this does, Python begins by checking whether password is equal to the correct password. If it is not, it will then move onto this line and check if password is equal to hello. If password is equal to hello, it will print this line of code. And if it is not equal to hello, nor equal to the correct password, then it will do the else part and print you are not logged in. The reason why this else if, written as elif, is so important is that if this was true, then only this could happen. So only one else if or one if can happen. This is very important because else covers all other options, but else if covers a specific other option than the first. Because if we would put this line in here, it would print even when the password is not hello. But we want to, this is just to add exceptions, etc. And you will see in the next few videos how we can use these structures, use these use these logic structures to our advantage and how to use them to make a program. Now let's just run this. We'll save it as logic structures.python, always remembering the .python ending, and we execute it. Please enter your password. Now, what was the right password again? It was Newton, I believe. You have been logged in. Okay, success. Now let us see, let us see what happens if we restart the program and type in an incorrect password. You are not logged in. Python checks what you give, sees, okay, it is not correct, so it does not do this. It is also not hello, so it does not do this, but it's something else, so it does this, with printing the line. Now, one more time, we have a third option. What if we write hello? This is the else if part of the code. The password is not this, not the correct password, but it is another password, hello. So it will print this line of code, but it is not just anything else, it is this, so it will not execute the else part of the code. Even if this is not completely clear by now, the next few videos with examples and more explanations on this will clarify when to use these if-then statements, how to use them, and next thing, we're going to make a calculator where you can choose if you want to add or subtract numbers.